Hello, welcome to the AWS for Industrial Web Day session, solving workplace safety management challenges using IoT beacons and the AWS Cloud. In this session, we will hear from AWS partner Klika Tech and EM Microelectronic as they explore how enterprises are navigating the complexity of enterprise worker safety, systems for gathering, storing, and safeguarding location and movement data of potentially thousands of people. I'm Amanda Lowe from the AWS IoT Partner Acceleration Team, and with me is Manolo Morales, Head of Business Development for the Americas at Klika Tech, and Matthew Donham in the Wireless and Sensing Business Unit at EM Microelectronic. Manolo has more than 15 years of experience in the M2M, IoT, telecommunications, and wireless industries. And prior to Klika Tech, Manolo held senior executive roles at several Fortune 500 corporations. Matthew manages module programs in the Wireless and Sensing Business Unit at EM Microelectronic, and he has over 35 years of experience in product development. At EM, he oversees Bluetooth beacons, products for asset tracking, healthcare, IoT, and other verticals. Gentlemen, thank you for joining us today. I will now turn the presentation over to Manolo Morales.
Thank you, Amanda. This presentation looks at the impacts of a contagious disease like COVID-19 in the workplace and the need to increase worker safety and efficiency for future-proof operations with the introduction of solutions like contact tracing. We look today at threats facing workers and industrial operations and the approach that went into developing a solution that considered the multiple issues for introducing contact tracing procedures in the workplace. We'll present how the elements came together to develop a secure, modular, and scalable IoT platform together with our ecosystem partners, EM Microelectronic, with their small and lightweight wearable beacons, with Lenovo, with their industrial nano IoT gateway, and everything powered by AWS IoT service to provide a reliable solution for employee safety in production environments. But first, a quick glance on Klika Tech, who's a global IoT, cloud-native, big data solutions development company with headquarters in Miami, Florida, and offices in North America, Europe, and Asia. Our co-creation process gives customer a one-stop shop convenience to find end-to-end solutions to complex business challenges. Our experience covers the full spectrum of IoT and cloud-native product development, from consumer to industrial IoT, including big data, data analytics and visualization, machine learning, AI, and computer vision for multiple industries and applications like industrial and manufacturing, connected spaces, asset tracking, automotive, and several others. We are a AWS Advanced Tier and an IoT competency partner for AWS with extensive experience with FreeRTOS and Greengrass and many other service delivery designations. Klika Tech collaborates with AWS to enable turnkey access to AWS IoT and cloud service for fast, secure, and also scalable deployment of customized IoT applications like contact tracing, which you'll see today. So the concept of contact tracing has been used to control the spread of contagious diseases in workplaces for years, but it has been done in a very manual and time-consuming way. Today, wearable devices can be utilized to monitor the new social distancing guidelines and facilitate the contact tracing analysis in case an individual tests positive for a contagious disease like COVID-19. The CDC, which is the Center for Disease Control, recommended as a social distancing guideline to stay at least 6 feet away, as the threat of person-to-person transmission will likely continue in the near future with new variants of the virus, even after majority of people getting vaccinated. So it's estimated that when a person is diagnosed with COVID-19, determine with whom they came in contact will require an average of 36 individuals to be traced. So in a production environment, if you only spend 15 minutes reaching out to those 36 individuals, it will require almost 9 hours or entire workday just to warn these people that they were in close proximity with an infected individual, that they should get tested. So industrial operations are only adopting new re-entry procedures, but as well, they're adopting long-term solutions that will enable to quickly adapt to this new reality, and both based on the ability to capture, store, and analyze data. So IoT and cloud solutions replace manual processes, providing faster, much more economical, and more accurate results to improve worker safety and to ensure business continuity. This pandemic emphasized the impact of unpredictable threats on workforce health and business continuity, and the ability for IoT-driven contact tracing solutions to protect more effectively the workers and the businesses. So enterprise needs solutions that not only screen employees safely and without disrupting their normal day-to-day activities, but also provide them visibility to ensure that safety processes are being followed in compliance with their environmental health and safety procedures. So together with AWS and our partners EM Microelectronic and Lenovo, Klika Tech developed the platform to provide companies a simple, lower-cost solution for gathering and analyzing person-to-person contact data using discrete IoT beacons. The contact data is gathered by EM Microelectronic wearable beacons and is aggregated and offloaded to the AWS Cloud via the Lenovo Nano IoT Gateway using BLE or Bluetooth Low Energy technology. The IoT contact tracing reference kit developed by Klika Tech uses EM Microelectronic low-power beacons for data acquisition that helps providing business information about who is in the premise of the company, where are they operating, and who is working together, and recording how much time the workers stay in close proximity to each other. So applying IoT technologies to contact tracing enables the application to be future-proof, also secure, modular, and definitely very scalable. As I mentioned, our IoT contact tracing reference kit was designed in collaboration between several companies with Klika Tech, AWS, EM Microelectronic, and Lenovo. The kit is powered by AWS IoT platform, which enables companies to gather, store, and quickly analyze contact tracing data from hundreds or even thousands of individuals as an analytics tool for quick decision-making to monitor health and safety compliance on the workplace. The IoT contact tracing reference kit also enables businesses to monitor worker-level proximity touchpoints and also building occupancy for database decision-making. The EM Microelectronic EMBC22 beacons are very small and low-power devices that alert the individuals if they are staying too close to each other via proximity alerts, as well as they collect data for all these proximity events with a long battery life that can last up to several months. The Lenovo Nano IoT gateways running AWS IoT Greengrass ensure reliable device-to-cloud connectivity and turnkey access to AWS Cloud services. Klika Tech integrated the whole solution and developed a custom dashboard for convenient visualization and reporting of all the contact events between the beacons, which stay in proximity, meaning less than 6 feet apart from each other, and also reporting how many minutes they stayed in close proximity for every single contact event. IoT and edge computing technologies are powering smarter operations and leading to higher productivity and faster decision-making on industrial environments. As the demand for computing power at the edge increases, the edge devices as well will also need to deliver more performance as they are executing more complex tasks. So as part of our IoT contact tracing kit, we've selected the Lenovo ThinkCenter M90N IoT gateway that runs AWS IoT Greengrass as a foundation for a secure connection with the IoT beacons from EM Microelectronic as the edge devices. The Lenovo Nano IoT gateway also ensures reliable device-to-cloud connectivity and turnkey access to AWS Cloud service, as this product has been specially designed for high performance and versatility for industrial applications. The Nano IoT Gateway also offers several connectivity options, including cellular, LTE, 4G, as well with Wi-Fi and Bluetooth for easily connecting devices and sensors to the cloud. So Klika Tech integrated all the components and service to provide a scalable and easy to deploy contact tracing solution. The IoT contact tracing kit shows the EM microelectronic EMDC22 low power beacons in wearable wristbands using Bluetooth low energy connectivity for collecting data in a range of environments. And also we can consider to use the ruggedized version, the EMBP01 beacons that could be integrated for use in harsh industrial environments. The Lenovo Nano IoT gateways run AWS IoT Greengrass and also Lambda agents, allowing continuous local operation, even in the event of a disruption of the connectivity from the gateway to the cloud, and enable transfer of data to AWS IoT for advanced service such as analytics. Data is then ingested by AWS Cloud using service like AWS IoT Core, as well AWS Lambdas, API Gateway, DynamoDB, Amazon Cognito, and Amazon S3 and Amplify for convenient visualization and reporting of the contact tracing data. Depending on the application and customers' requirements, the integration of AWS service opens a wide range of possibilities for additional insights and value to be gathered from all the data. That could also include facility usage, for example, and building occupancy, as well as material flow, position, and status of assets within a facility. So from sensors to gateway and gateway to the cloud, the solution provides via AWS IoT infrastructure reliable and very cost-effective analytics tool to allow our customers to return safely to work. So this concludes my presentation, and I will now pass the word to Matthew.
Thank you, Manolo. Manolo has discussed the key elements of a contract tracing solution and the way Klika uses their system integration to bring together the Amazon AWS backend, the Bluetooth gateways, and the beacons into a complete solution. I'm going to drill deeper on the beacons because their features are a key component of a successful integrated solution. I work for EM Microelectronic, which is a company within the Swatch Group, a global maker of a number of watch brands, including Omega, which flew with astronauts to the moon. With our sister companies, Microcrystal, Renata Batteries, and Swiss Timing, we provide technology into the Swatch Group and its products, but also to independent customers around the world. EM specializes in small, low-cost, ultra-low power solutions for sensing, power management, supervisory circuits, timing, and capacitive touchscreens. We're also a global supplier of state-of-the-art solutions for RFID, NFC, and Bluetooth. EM introduced its first Bluetooth BLE controller, the 9301, in 2010. At the time, it was the lowest power BLE controller available. We followed this with our first beacon, the EMBC01, which served for asset tracking, indoor navigation, and other markets. Our current system on a chip, the EM9304, continues our ultra-low power tradition, and we'll be introducing our new SoC, the 9305, later this year. This slide shows our design goals, the key benefits that distinguish our beacons in the market. The first and probably most important is that they be small and light. These devices are going to be on people, on lanyards or wrist straps. They can even be embedded in clothing. They'll also be attached to or integrated into tools and other devices. So obviously, in order to keep them from being annoying, they need to be as small and light as possible. The second thing is low power. A low power device requires a smaller battery, which again goes with the goal of being small and light, and also is less expensive, of course. It's also valuable to have a long RF range. This reduces the cost of infrastructure. If you're putting these devices for contact tracing on everyone in an office or every student in a school, then you'd like to have their broadcast strength be as high as possible so as to minimize the number of Bluetooth gateways that you have to have in order to avoid dead spots in the building, which reduces the cost of those gateways themselves, and of course the not inconsequential cost of installing them. We also support over-the-air updates. In a security-conscious age, the idea that fielded devices can be given a new version of the firmware according to the latest news on security is an important way to avoid obsolescence. And finally, it's important that they be easy to deploy and manage. This includes the over-the-air programming that I just mentioned, and also the ability to easily replace batteries in certain applications for people, again, like students or office workers who might be wearing the beacons for a very long time. We provide a family of beacons with different combinations of these features. The EMBC family has a replaceable battery, a button for activation or signaling, and one or more LEDs for interacting with the user. The EMBP family, on the other hand, is designed to be more rugged. It's potted in epoxy, so it has a higher environmental rating. It is more resistant to being crushed. It can be submersed for at least a few minutes and is more suitable for applications like a construction site or other places where the environment is going to be more taxing. Both families feature accelerometers for activate on motion, drop detection, and other applications like that. Obviously, the topic of our presentation today is contact tracing, which falls under the broader heading of needing to track people. In hospitality, it provides two valuable features, the ability to track people. The first is the features offered to the customers, the ability to keep track of other members, their location in the park, and just simplifying interaction for figuring out where the rest of your family has gone. For the provider of an amusement park or a cruise or a similar hospitality resort, it supports analytics on the part of the establishment to help them understand how park resources are being used. This can be very valuable, obviously, in accomplishing efficiencies and determining where the highest traffic and greatest interest, therefore, is. In healthcare, it can be used in hospitals and nursing homes for keeping track of patients and residents. This is useful in general, but in combination with the accelerometer provides a very valuable feature for patient welfare. It can tell you if the patient has been immobile for too long, particularly, say, someplace other than bed or the lounge area, where that immobility, for instance, in the bathroom, might suggest that a welfare check is required, and the integrated system is able to perform that function automatically, calling attention at a manager or nurse's desk that a welfare check is required. The benefits for contact tracing are twofold. The first is as a proximity warning. The EMBC 20 family can be used with its LEDs to signal when two people have come within a certain threshold, particularly if that contact has been too long, and encourage social distancing. Just as important, the system can be used for contact tracing. In this case, there need not even be LEDs, which might be more desirable in hospitality applications where you don't want to call attention to how often people are in proximity with each other, where the beacons will nonetheless report that proximity through the gateway to the AWS backend under Klika's firmware management and accumulate the data that would be valuable should there subsequently turn out to be an outbreak. Thank you for listening to our presentation. Amazon, AWS, Klika Tech, and EM Microelectronic look forward to the opportunity to help you provide state-of-the-art solutions for contact tracing and other IoT applications. Take care.